Hello everyone, welcome to ICN Free Classroom. Today we will talk about principles of network applications, this one. The goal for us actually we want to that you know the conceptual and implementation aspects of application layer protocols. And of course, we would rather know transport layer service models. And of course, we want to rather know some paradigms here. Some models, we have client-server, peer-to-peer. And of course, later we will rather have some actual application layer protocols, including HTTP, SMTP, DNS, and the others. Finally, we will already have the concept to have the programming network applications. So of course, we should have the concept socket API. Well, so this is a goal for the principles of network applications. Well, about paradigm, we have two paradigms that says two models. All right, and here this is the meaning in Chinese. Well, network applications. About the examples of network applications, we can have social networking, web or web page, text messaging, email, and the others. So that says we should have some application. The application will utilize networking. If so, then we will have the network applications. And of course, among all of the possible applications, which one you prefer or which one is your favorite application? Maybe you prefer real-time video or maybe conferencing or something else. Or maybe you prefer network games. Or maybe you think you want to use file sharing based on the P2P paradigm to have the file sharing. So you should have your own one, and based on this, then you can think about that one can be applied to the current principles or not. Well, let us think about our way to create a network app. Network app, actually we should have the program. And this program will be run on N systems. And of course, it is the network app, so we should have the communication over the network. For example, if we consider web, and then web server software will communicate with the browser software. This is actually the necessary aspect for the network application to write the program. And should we have the program for the network code? Of course, no. For us, actually, we just develop the application for the end system. As for the software for the network code, it's not the business of the developer. Well, so we have the network code devices, but we don't have applications. Well, because of this, we only allow application on end systems. This way, we can speed the app development. Why? Because all the end system can divide its own application. Then this way, we don't have the limitation set to the creation of a network app. So that's why we can have the rapid app development. Well, so look at this. We have the network app, right? So we have app layer and app application. So that we allow each end system can communicate with each other. Well, this is a goal for the network app. You should understand we only focus on end-to-end. Why? Because we don't consider the possible app within the network core. So it won't be necessary to have apps. Well, so if we want to have the creation for network app, we will employ one of the paradigms. The first paradigm we call client-server paradigm. Client-server, so we have a server client. And we have a single server for the current case. And we have multiple clients. For the server, actually, it's an always on host. And the IP associated with the server should be permanent. That says we cannot change the IP for the server, or otherwise client cannot connect to the server. Well, for the server, only single server. In fact, we can have multiple hosts work together so that we can have the data center. Or maybe you can think we have a lot of servers to work together. Why we want to do so? Because multiple servers work together, then we can have the scalability. Well, so data center for scaling, this is a reason to have multiple servers. And clients, actually the client will connect with the server, and so that we can have the service provided by the server. Because it is a client, it doesn't mean the client should be connected. So sometimes we may have a situation like this, intermittently connected. That says, oh, I want to connect, or maybe I don't want to connect with the other host. So this is a possible situation. As for the IP, it won't be necessary to have a permanent IP associated with a client. Well, if we have the client-server paradigm, then here, client, all the clients, they cannot communicate directly with the other client. So, client-server paradigm, we won't allow client to communicate with each other. So this is the restriction for the current paradigm. Well, for the current network layer, can we have some possible example to use the current paradigm? Yes, for HTTP, that says web. Yes, we apply this. For email, IMAP. Yes. For FTP, yes, we use the client-server paradigm. Well, we have another paradigm. Here we call peer-to-peer. And peer-to-peer architecture, we don't have any server. Or maybe we don't have always on server. That says the paradigm does not rely on the server. Or maybe does not rely on the server heavily. Well, that says you don't have the service from the server possibly. If so, then hosts need to communicate with each other so that arbitrary end system directly communicate with the other end system. And here, end system and end system we call peer. Because of this, we call the current paradigms as peer-to-peer paradigm. Well, we don't have an always-on server. Then peers cannot request service from the server. Instead, peers request service from other peers. Why we want to use P2P paradigm? Because we want to have the self-scalability. Why self? Because peers can take care of the service for the network. And if so, then we call it the self-scalability. Well, think about this. Self-scalability, new peers bring new service capability. And so that we can satisfy the requirements or maybe demands of the current network. Well, talking about peer-to-peer paradigm, peers are intermediately connected. So this one, similar to the client in the client-server paradigm. But the current peer, we won't have the always-on requirement. So peers are intermediately connected, and they can change or they may change IP addresses. Because of this, then to have further management, it won't be a complex task. So how to do? Of course, we should have the proper way to handle this, but currently it's a discussion simply. Therefore, we won't have the further discussion about the complex management. Well, peer-to-peer. In short, we can have a notation, this one, P2P. And of course, P2P, which one will be the explicit application? It should be P2P file sharing. All right. Well, we want to have the network app creation. And we have two paradigms. All right. So two paradigms, each one actually we have the app. About the current app, actually we will have the program, we will have the process. All right, you see, we have the program, and this program we will call it's a process. So we have the current definition. Process is a program running within a host. Well, because of this, we have a process for each host. That is within the same host. And assume we have two processes to communicate. How to do? We will have the inter-process communication. You see, within the same host, should we have a network? No. No need to have a network service. Because of no network service required, therefore we just have the inter-process communication. And it is not the network or networking. And this one, it is defined by the operating system, OS. However, if we have a process in different hosts, then we should have the message exchange. And how to do? We should exchange in the network. All right, so we will have the networking or using some API for networking. Well, because of a process, and then we should have the client process, server process if we consider client-server paradigm? Well, for client process, actually it's a process initiated by the end system, actually the client. As for the server process, actually this is a process waiting for possible connection or contacted by the client. This is the client-server paradigm. And how about application with the P2P architecture? In fact, for each host or for each peer, it should have both client and server process. Let me emphasize, for the P2P application, actually for each peer, it should have both client and server process so that we will have the possible communication between each pair of peers. Well, so this is the program or process, and the program or process, if we should have the communication within the same host, then we have the inter-process communication. If no, then we will have the necessary networking. Well, to have the networking, we should have the following concept. It is called circuits. What that means, circuits, this one. So in Chinese, we can have some meaning like this. Well, circuits, actually circuit means here. We have a door. That says we want to have a door and then exchange messages to the other side. And we simply call it a door, but it is not a door simply. In fact, we should have some service associated with the circuit. Well, look at this. Why we want to have the function of circuits? We should have some function like doors. That says process will send or receive messages to its circuit or from its circuit if we want to send or receive. Of course, if so, then we should have some function like a door. All right, so we will sending process shoots message out the door. That says push the message out of the door. If so, we send it to the other one, and the other one actually the lower layer. And the lower layer, then we will have transport infrastructure or transport layer. So that's why we have this layer, transport layer. We push the message out the door, but we will send it to the lower layer. And this from the viewpoint of the application. We just put it to the transport layer. So the others actually we never mind. So currently we will talk about the transport layer if we have the circuit programming. Well, as for the receiving, actually we will receive messages from transport layer through the door, through circuit, then we will have the message to be processed at the application layer. Well, so we have two circuits, circuit at the client and circuit at the server. Well, so look at this. We will have the OS again. Even for the networking OS again to have the proper setting. Well, previously we have the concept of circuit, so that we will have circuit API. And for circuit API, actually we will have some addresses. And addresses, then we will have the issue of addressing. This kind of addressing is ID. And ID actually is an identifier. For the current version IPv4, the length of IP is 32 bits. 32 bits, and then we have the IP address. And before we go further, we already have one question. Does IP address of a host does IP address used by the process only? Actually, no. Why? IP address employed to identify the process only? No. Why? Because we may have a situation, many processes within the same house. For this case, how to do? Actually, we will have the new way. We don't have IP simply. IP, we still have a port number. All right, so we have a host and like a bay. And then we have a port. Right? So like a bay, then we have a port. And using the concept, so within IP plus port number, then it serves as the ID to identify a process. Well, so you can think about this, about the port number of some well-known servers. HTTP server, we have a fixed IP, a fixed port number. Mail, we have a fixed port number. They are 80 and 25 for the HTTP, for the mail. For example, we have a web server IP address for reference, but server will have the fixed port number. Well, look at this. We have a web and we have a client server. We just talked about the server side. About the client side, so we should have an IP for the client. And how about the port number? The port number can be anyone else. Assigned here. Assigned by the OS. So we don't know the current port number for the client. So that's why we just let it have the port numbers of servers rather than the port number for the client. For the client, actually, we just ask the OS to assign. Well, we should have the ID. ID, we will have IP plus port number. And furthermore, we want to have the creation of a network app. And network app actually will rely on which app protocol? Well, why we want to have a network application to rely on protocol? Protocol says, oh, we have the known rules. And so that anyone wants to create some possible network app, then we can use it. Because we want to use it, so we want to mention some rules. First of all, it can be types of message exchange, syntax, semantics, all right? And message exchange, we may have request, response. And syntax means fields, the meaning of their fields, and how to have the separation. So there should be the linearity that says they should be separated. So we have the individual, or maybe each field can be separated properly. Of course, meaning is, it is the semantics. So we have the possible rule. Put all the possible rule, then we have the app layer protocol. And here, this is necessary aspects of network app protocol. And we should have the definition to have a possible rule for the network app. Well, for the protocol, in fact, we can have the known protocol. And this kind of known protocol, it is called open protocol. Open protocol says anyone know the protocol can implement the protocol, and so that possibly the client and server can work together. It doesn't mean if we follow some open protocol, then they won't communicate with each other. It should be, because of open protocol should work together, and in the internet we can define RFC. All right, and anyone has access to the protocol definition, knowing the protocol, and then it can implement, and so that this kind of app can work together. So we allow interoperability. For example, web, email, then we allow them to work together. Anyone can create this kind of app if possible. But sometimes it doesn't mean we allow the other people to know the protocol definition. Therefore, we have a different one called proprietary. Proprietary protocol says this one. Oh, only the owner know the details, or otherwise no one know. If so, this is called the proprietary. And we may have a proprietary protocol. For example, Skype. Even currently, we don't have the service of Skype. But in the past, actually, Skype is one of the possible proprietary protocol. And proprietary protocol, should we have the consideration of interoperability? No. Right. Well, we want to create network app, and actually network app will pass through socket, and then we have a transport. So send message to the transport layer, and then we want to know what transport service does an app need, or what transport service provided to the app. First of all, we can have this kind of service. Integrity. Integrity says the reliability. 100% reliable or no? Well, for file, for web, actually we don't have any errors. So we should have 100% reliability. But for audio, for video, even we don't have the 100% reliability, is still okay. So the other app can tolerate some losses. This is the first aspect, data integrity. To have the 100% reliability, oh, we don't have 100% reliability. And next one is timing. Timing says some time or delay. Well, for some apps, actually, we allow a bit delay, but some a bit actually try to have a really low delay. So we have a timing aspect to consider that one. And next one, we consider throughput. Well, for throughput, actually, we want to have the necessary bandwidth, or maybe, okay, it doesn't matter, either one. So first of all, some apps, for example, multimedia, we want to have a minimum bandwidth requirement. And then if it's called the necessary requirement by the apps. And another one, elastic app. Anyone you want to let me have, I just use it. So then we have the elastic apps. So we can consider a throughput to have necessary requirement or no requirement. And next one, to have the security or not. Security consider encryption, of course, data integrity for sure, and the others. Well, this one, integrity. Well, transport service. We want to have the requirement by app, so that's why transport service requirements. You can have some different apps, file transfer, email, and the others. That'll check data integrity, no loss. But for this, we can have the loss tolerant. And for messaging, sure, no loss. I think you can know why we have no loss or loss tolerant. Specifically for low tolerance, it's multimedia. Right? Multimedia. Well, for file, actually we're allowed to have the elastic throughput. Elastic. However, for multimedia, no, we should have some capacity requirement. As for time, similar to file, actually no timing requirement. But for multimedia, yes, and yes, and yes. And for text messaging, actually, we expect the message return. So sometimes you may have the timing setting. But sometimes maybe you think, okay, I just want to exchange the message. When you will check, it doesn't matter. For example, line. And then we will have the timing set to no. But line set to no, no. Sometimes you expect to have the instant prompt. But if you use line, you cannot have that expectation because sometimes they don't want to respond actually instantly. So for text messaging, sometimes we have the requirement of timing, or maybe sometimes no. Well, if we have the possible features or requirement like those, and then we can check two possible services provided by TCP or provided by UDP. TCP, UDP, both of them are transport layer. All right, so we can have the transport layer TCP or UDP. For TCP, checking this reliable. And TCP provide flow control, congestion control, and connection oriented. However, about timing, no. About throughput, no. About security, no. By this, we have the service reliable, flow control, congestion control. Need to have the connection setting, so we have the connection oriented. However, for UDP, unreliable, and anything else, almost no. In fact, we should have the minimum one, but here we go, almost no. And almost no, why? Why bother we should have a UDP? Something like we have service type 1, and in fact, we should have the diverse service. That's why we have UDP. And consider to buy a house. if you want to have the plain house, that's okay. So this one serving as a plain house option. All right. Well, if we have the possible service FTP, TCP, UDP, then we can consider the previous app again. For this one, we have the corresponding protocols. All right, and actually for this, because of game, so it should be proprietary. But we want to consider for all of these, we should have some choice of TCP or UDP. All right, for file transfer, which one we want to have it? Because we have a connection. You see, if you want to have a file transfer, you need to key in and then connect. So it's TCP. And email similar to this one, we have TCP. And web, we have a connection, TCP. So we have a one feature, connection. And actually, integrity. So we have a reliability requirement. So TCP. But for this one, because of multimedia, and then it will be UDP possibly. Game, something like UDP possibly. Why? Because we don't want to have a flow control or congestion control. Because flow control, congestion control, it care about the bandwidth. However, for multimedia, we have the flexible bandwidth requirement. So multimedia, internet telephony, we call it multimedia, and it's multimedia. So normally for that, we will set it to UDP and set it to UDP. But look at this. We have a streaming video audio. Streaming actually will based on web. So it's dash. And then because of web, so it's TCP rather than UDP. All right, so for some consideration, we will have all of the possible association with TCP or UDP. I already have multimedia using TCP or UDP, prefer UDP rather than TCP. But is it possible to employ TCP? Sure, you can do that one. But if you have the TCP, then you will have the bandwidth limitation there because of flow control. Well, let me mention one thing. How about DNS? DNS actually, which one we will employ? Actually, for DNS, we will have UDP. And later we will have the reason why we employ UDP. And make it simple. How about if we choose TCP? Choose TCP says, oh, all right, if we have a report for the status, and the report sent to the server, not successful. Not successful, then we will have a retransmission. For DNS or for SNMP, Network Management Protocol. For all of these, actually we'll have the maintenance. The maintenance will have a lot of repo. For all the repo, in fact, we can have the regular transmission, even if failed to reach the server, but it doesn't matter. So we don't want to have the extra burden, so we choose UDP for DNS or for SNMP. All right. Well, because we don't have the consideration of security. For TCP or UDP, but is it possible to have the security enhancement for TCP? Yes. So the normal one we call vanilla TCP. So this is the original one. Original TCP. And original TCP we call vanilla TCP. For vanilla TCP or UDP, even for UDP, we don't consider security. So no encryption. And so that we can have a clear text for vanilla TCP and UDP. However, if you don't like it, actually you should have the enhancement. How to have the enhancement? You can have the transport layer security. Transport layer security, initial TLS. And so that this one can provide the encrypted TCP, data integrity, and even the authenticity. And authenticity here, it is the capability of authentication. In Chinese, something like you have these. All right, authentication. Well, if you want to have that one, you can have a TLS, and actually TLS above TCP. So you have a TLS. And above TCP, so that TLS is implemented in the application layer, the current discussion. So we can have a TLS based on TLS service, for example, library, then we can have the security. And if so, then TLS will use Circuit API, and so that we can have the security service provision. And this one can be seen in Chapter 8 of the textbook, but not covered in our course, ICN. So we won't check that one. Well, so this is the final page for the current topic. Principles of network application. And that's all for today's topic of free classroom. All right, that's it. And see you next time. Bye-bye.